Good morning, everyone. Welcome to the EasyPower Tuesday Refresher Series. My name is Jim Chastain. I'm with the Application Support Group here. And today's topic is some of the features of EasyPower Scenario Manager. This is a tool or capability that's been included in EasyPower for years. And it always surprises me as we conduct workshops in different locations how frequently people cite the fact that the features in the EasyPower tool save a lot of time compared to some of the competitors' products. And so that's what prompted this particular topic. So again, welcome. Should be a fairly succinct presentation today, and I do appreciate you joining us. First, I'd like to start with a real quick poll question, if you would please. Normally, when you're doing a project, how many scenarios do you typically include? And appreciate you participating in the poll. The topic comes up frequently, especially for new users, and we'll get into some of the guidelines as we go through the material. But in part, what prompted this topic as well is how frequently I receive files where the scenario manager has not been properly set up. So it looks like we have our quorum here. Here's how people have weighed in on this. Good. And then next question is, do you usually create scenarios with and without motor contributions? And again, some of this may be something that you do all the time, excuse me, without thinking about it, which is fine. And hopefully we'll be able to offer some insight into how to expand the use of the tool for your needs. So, excuse me, here's how folks have weighed in on this one. About 3-1. And then finally, what incident energy would you think should be labeled when the worst case on a particular bus is the standby generator, emergency generator supply? And again, this is not a trick question. It goes to, I guess, company policy and somewhat how you define the contents of the label. And so we'll just touch on that at the tail end of things. But I do appreciate you kind of providing some feedback here. So give this another 5 seconds. And here's how folks have weighed in on this. About a 2-1. Excellent. Okay, so the agenda for today is essentially do a once over of the EasyPower Scenario Manager capabilities, and emphasizing, and probably I want to re-emphasize this a couple times, make sure you do all your changes with your base case as far as anything that affects the whole system. And then understand what you're saving whenever you make changes, or where the tool asks you if you want to save it. Sometimes you have unintended changes that may or may not be part of your intent. And we'll talk about some different workflow impacts, about how to use the scenario manager and make it more productive from the way you deal with it. And then a couple samples, one in both ArcFlash and another in PowerFlow. Turns out the EasyPower Scenario Manager was originally generated or created to work with PowerFlow to be able to compare different scenarios. And it's been kind of overshadowed, or that application has been overshadowed with the focus on ArcFlash. So as I mentioned, what kind of prompted this is how frequently I'll receive a large file like this where they've gone through and diligently created a number of scenarios, but then when something changes, it necessitates a large amount of deletions, and it's not really clear at this point if it was because they lopped off part of the mill or if they improperly set up the scenarios to start with. So that's kind of where I wanted to start the discussion today. IEEE 1584, when we're talking about arc flash calculations, suggests that you want to have an analysis of with motor contributions, all large motor contributions, and without. And the inference is to use max utility fault current in all large motors, which presumably would give you the worst case equipment duty, and then potentially minimum utility in no large motors, which potentially could give you the worst case arc flash. Now, this is kind of a general rule of thumb. It doesn't apply to all systems, but it's a way to kind of segregate what you're looking at and what your focus is when you're kind of going through this process. In a complex system, things are a little bit different, and there you need to really understand the configuration of the system. And the reason that I asked the one question as I did is that when we're calculating arc flash and worried about labeling, the criteria there is any bus that needs to be opened up and worked on while it's hot are those that require the arc flash labeling and calculations. Now, if we have an emergency generator, most often when we're in standby generator supplying as the energy source, that will be the lowest short circuit fault current, and consequently the more conservative or the higher instant energy calculation. But if we never intend to run on standby power and do maintenance, then it could be debatable that may or may not be appropriate to put on the label. So that's why I say this goes to company policy, and that's something you have to determine internally. Now, obviously, when you get to more complex systems with multiple cross over breakers and multiple sources, then you have a considerably higher number of scenarios that you need to look at. So here's kind of a typical example that I use frequently, and let's jump into this and talk about it. So what we have here is a cogen situation where we have the ability to supply both sides of our feeder system through one or both cross-connected energy supplies. With the design, the intent was to be able to supply both halves of the plant with a single source through the cross-connect. So first and foremost, once we draw a one-line diagram, you want to make sure you save it, and then at that point it becomes the base case. If you haven't saved the file, then you actually can't even access the scenario manager in terms of creating new scenarios. So the first thing you want to do is save your base case, and that becomes, if you will, the generic normal operations for your system. And then in terms of creating these scenarios, so now that I've got my base case saved, I'm going to go in and then set up these different configurations and save each. So this has already been done. Looks like we have about 7 or 8 different scenarios, and they are labeled such that they give us some idea of what the configuration is as we pick them out. So if I select cogen only tie closed and open that scenario, you can see the tool now has highlighted, color-coded the breakers that are changed from the base case. In this case, we're isolating the utility side of the plant, cross-connecting the 2 feeders switchgear, and then supplying everything through this single transformer on the right. So that gives us the cogen only tie closed configuration. Likewise, if we go in and open another scenario And this is another point I want to make. As we go to open another, either the base case or another file, another scenario, the tool asks us that, do we want to save the change or store the change? All I've done in this point is, let me just kind of emphasize this. All I did to this scenario was zoom in, and the tool saves or stores our zoom and pan settings as we look at the scenario. So even though I haven't really made any physical changes to the model, it's asking me if I want to save when I now try to go out to the scenario manager. So in this case, I don't want to save anything because all I did was zoom in a little bit. And I'm going to open up my utility and cogen tie closed. And again, we can see we have both utility and cogen online supplying through this single transformer and then cross-connecting again with the color coding. Now that once we've got all this done, the purpose is to do basically a comprehensive analysis on the whole system. Now you'll notice on my list of scenarios, I have a without motor. Now, if in some cases, I may want to have a combination of these other configurations and doing a without motor comparison at the time. So in this case, without motor was basically starting from my base case, and all I've done is disable the system that has motors. I did that when I'm in database edit. I can right click and uncheck this checkbox here which says include motor contribution. So for this file, I started with the base case, I unchecked that motor, and I saved the scenario as labeled without motors. So now at this point, I can go into my scenario manager and under create scenario comparison report, create an arc flash study. I'm not going to change anything. Again, it was just the zooming. I'm not going to save any changes. And then it goes through and creates a default report showing each bus and then telling me with a red check mark which scenario is the worst case for that. And we can see it varies from bus to bus. The tool also lets me just display only the worst case scenario. And in the case of at least a couple buses, on standby generator is the worst case. Now again, if my company policy is to allow the potential for operations or inspection or maintenance while we're in standby mode, I am of the opinion that I want to label that because it'll probably be the worst case for that bus, and make sure that anybody working on that equipment needs to be aware whether or not it's in standby, supplied by the standby generator. Now, just a real quick aside, if I wanted to print these labels from this list and I wanted to include the scenario description, I go into my normal print template, my start printer, my print interface. I'd start the editor, and then from my HTML editor over here on the right, I'd insert text. So what I want to do is indicate what scenario I'm in on each of my labels. So I'm going to insert text. It placed my little inserted text right here, and we're going to describe a scenario. Oops. Yeah. I'm going to put something cute like scenario is. Then I'm going to add a variable. In this case, I can pull it down and find my scenario name. And then I'll put a little quotation mark outside of that. And so now when I go to each label, as I scroll through here, it describes what that scenario is. Now, presumably I'm training my people to understand what that means and be able to use that information if they are in the process of dealing with any kind of adjustment on that piece of equipment. But at any rate, that's how I insert the scenario, the name of the scenario on a label. So I'm going to close this. All right, so again, these are features, if you've been using EasyPower for a while, they're probably not new, but I want to emphasize that you always work from the base case and don't get yourself into a position where you end up deleting a bunch of stuff on or making configuration changes, and because you didn't do it in the base case, they don't necessarily show up in the other scenarios where you want them. Now, the benefit of all this, when I'm in the base case, if I come and want to change one of the components in my system, let's say this particular breaker, we change to be a Cutler hammer, and I'm just going to wing it, so this is not something that I'd recommend. But if we want to change the breaker on the whole system and not have to redo all of my scenarios, I would do something like this. And by changing just this breaker on the base case, I would be able to have all the scenarios updated at the same time. So I'm kind of winging it here, but hopefully we'll get something done that works. Okay, so I've saved this in my in my base case. And so now if I go back and open up a scenario, I do want to save this. And now as I go back and open my utility only tie closed, I can see now that this now has been changed from a GE breaker to a Cutler hammer breaker in every scenario I have. Okay, so that was using Scenario Manager and looking at, well, now the other thing I wanted to emphasize here is how important that is on equipment duty. From Scenario Manager, we can create an equipment duty comparison report and determine which is, let's go ahead and save these, which is most restrictive in terms of the equipment duty calculations. And more often than not, these will be not be the same ones as they are in Arc Flash. And again, the reason for that is that we're looking for the highest current, and any place that the current is exceeding the rating for that particular bus or piece of equipment. And what you would be looking for at this point would be a negative number a positive number that's flagged in red. And in this case, we don't have any that causes an issue for equipment duty. But even though it's actually counterintuitive as far as the Arc Flash, it's especially when you have cross connects, it's an area that you really want to be double checking when you're working on older systems. Okay, so there's one other thing I want to touch on before we get through today, and it has to do with PowerFlow. It turns out, as I mentioned, the Scenario Manager was actually created to work primarily with PowerFlow, comparing different configurations or settings. And so the question came up here last week, how do I deal with the tap settings? If I go into my transformer and I've got some readings from my utility supplier that in the summer I'm going to have different voltage supplied typically, than I will during the winter. So how do I set up the taps on the transformer? When we're looking at the specification, under the specification tab for the transformer, we're showing rated kV and then the tap kV on the second column here. And this is where, if we're going to be changing the taps to deal with the changes on the incoming voltage, this is where it would be done. So the question is, how do we set these taps up to optimize what's going to be coming in from the utility due to the fact that it changes in voltage? If we go out and look at, and so my suggestion was the PowerFlow tool has the ability in a transformer to set up a load tap changer. And in this case, we're going to have this main transformer set up with a load tap changer that regulates on the 2 side and will changes the taps on the 2 side based upon whatever the optimum power flow solution will be. So this is the way we set up our base case. And so we set it up as a load tap changer. Then we save our scenarios with a, we're not going to save this because I didn't change anything. For my low utility, the utilities that says it will be at 0.92 per unit. So under the utility icon, PowerFlow, we set up the control voltage at per unit 0.92, which is the lowest point that the utility company said that they'll be. And then likewise, excuse me, in my other scenario, where the utility is high, we're going to set up the voltage there for the utility at 1.08. So there's a swing of about 16% from one extreme to the other. So the question is, so effectively we set up the base case with the one per unit, and then we're going to run PowerFlow and compare these other set points. So set with the utility high, we go into PowerFlow, solve the equations, and look at our voltage taps, and we can see with the high voltage in the winter, whatever season it was, to keep constant 13.8, we need to set it for 13.28. We need to set the taps to supply 13.2. If we go back to our database edit, open a scenario, don't change it, or don't save it, pick up the low scenario, run PowerFlow, and solve. Here, when the voltage coming in from the utility is low, the tap should be at 15.612 coming out to maintain our optimum 13K on this bus. And then finally, so these all have to be run manually, and what I do is print out a PowerFlow report for the transformer taps and make these comparisons manually, but this gives me an idea of how far off or what, or at least gives me some input to be able to make that decision. And so then finally, when I go back to my base case, it says you need to be in database edit. So I'm going to go back to my base case and not save anything, run PowerFlow. And so I got the 3 data points, and based upon what I know about the system, I can make some recommendations about how to set the taps up on the transformer. Now I got just a couple minutes left. Any questions on that, let me know. I got a couple minutes left, and I wanted to show you, this doesn't have anything to do with Scenario Manager, but it does have a lot to do with things that, especially on a large system, let's say here's a large system, and I'm trying to deal with power factor. So I've got a large motor bank down here, and I ostensibly have the potential for varying how my power factor correction is installed or applied. And what I want to do is see how it impacts my power flow, my power factor coming from the utility. I'm in PowerFlow, I'm looking at my options, and for my one-line output, for my generation, I'm showing MVA and power factor. So I want to be able to look at that while I'm adjusting those breakers. Well, rather than scaling back and forth and looking at this, here's what I want to do. Here's a suggestion. I'm going to left click and drag and select the utility part of this, and then I'm going to scroll down to my capacitor bank, hold down Control, and left click and select that. And I'm going to put this all on a new drawing. Now it says yeah, it won't fit. Yeah, I knew that, but watch what I can do. It's down here. I'm going to select it and then drag it up on this drawing. Now what I want to do is run PowerFlow. So if I run PowerFlow, there's my power factor. Here's my capacitors, and I can do this operations. I just put in a half a megavar capacitor, and I brought my power factor up to 0.913, which is not bad. I have also the ability to do it 0.2. I get 0.836. Now the other, so 0.7 is probably going to be optimum as far as trying to bring this up for power factor improvement. Now the beauty of this is like, okay, what have I done to the resonance of the system? So I'm going to go now from power factor to harmonics. I'm going to look at this bus and I'm going to say, well, scan on that bus, and what happens as I change that capacitor? So sure enough, I've got a resonance point here right above the fifth harmonic. Does that change or does that improve with my different scenarios, with my different combinations? So if I close that and close this, if I decide 0.7 is where I want to be, does anything really change? And the answer is no. All right, so I'm going to take one of these out. Does that change? The answer is yes. It moves the resonance point up above 6, closer to 7. So I may want to go in and reconsider how much and where I place those capacitors. And again, what I'm doing is emphasizing the what-if capabilities of the tool. So what I wanted to show is the fact that, one, I can run the analysis while I'm looking at a drawing. Two, I can isolate parts of my one line that I really want to inspect and compare as I'm doing these what-if calculations. And three, it doesn't affect anything as far as the one line, because now when we go back to the one line, it's still intact and it's doing what I need it to do. Okay, so what have we covered? Make sure you save, for starters, the base case, the file, and be aware as you make changes in any scenario that it may or may not, it more than likely won't be reflected back to the base case. And those changes include changes in pan and zoom, which may be inconsequential, and that's why the tool is asking you if you want to save since the last save pickup. Again, it seems to be a very clear advantage in terms of when you make changes to the system that you want to carry all across all your scenarios. Make sure you do it in your base case and you don't have to rebuild all of those scenarios accordingly. And then especially if you're considering taking something out, if you look at making a change in a scenario that has extrapolations or connections to a part of the system that you will be deleting in the base case, then obviously there's going to be some scenarios that need to be recreated or corrected or deleted at that point. So anyway, that's probably the extent of what I wanted to provide today. Hopefully you got something out of it. I want to make sure that everybody is aware that this webinar and others like it are available on EasyPower.com. We've updated the locations for the regional training for the rest of the year. You can also access the online training as an economical comparison to the regional training, basically the same material online. And for those of you with current maintenance, virtually unlimited support at availability for tech support at EasyPower.com. Thank you for attending today, and I look forward to talking to you down the road.